Hello there, my name is Tawfiq Omar Uthman, math teacher. In this video, I will explain Chapter 2, Lesson 1, Finding Limits Graphically. Limits is an important subject. Calculus is the mathematics of dynamics, whereas poor calculus can be viewed as a mathematics of constant. For example, an object traveling at a constant velocity can be studied with the poor calculus, whereas we need a calculus to study its motion when its velocity is changed. Here came the importance of limits to join the poor calculus and the calculus. What is the purpose of finding limits? The purpose of finding limits is finding the value of y. That means every time you need to find the limits, you must search for the value of y. And now, what is the limit? When the value of x approach to the number like c, in both sides leads to that the function fx approach to a number a, then a is limits. The following notation is used. Limit x approach to c fx equal to a. There are three ways to find the limits: graphically, numerically, and algebra. The first one, we take how we can find the limit graphically. To find limits in this way, follow these steps below. Step 1. Plot the graph of the function using points if the graph of the function is not given. Step 2. Move on the graph of the function closer to the value of x in the both sides. If in the both sides the value of fx approach to the same number, it is the limit. Example: find the limits of the function fx equal x squared plus 1 when x approach to 1. And now this is the graph of this function. When we approach to the 1 from right, as you can see here, when we approach to the 1, the value of y approach to the 2 in the right. When we approach from the right to the 1, the value of fx approach to the 2. And when we approach to the 1 from the left, you can see the y approach to the 2. That means limit when x approach to 1 for fx is 2. Note that the value of function fx is 2 when x is 1, or f1 is equal to 2. Another example: find limits when x approach to 0 fx when fx is equal x over square root of x plus 1 minus 1. This is the graph of this function. When we approach to the 0 from right, you can see that the y or fx approach to number 2. And when we approach to the 0 from the left side, as you can see, the value of y or the function is approached to 2. Or when x become closer and closer to 0 in the both sides, then fx become closer and closer to 2. It means that the limit when x approach to 0 fx is equal to 2. Example: find limits x approach to 0 fx when fx equal x over square root of x plus 4 minus 2. Here, when we approach from the right side to the number 0, then the value of x comes closer and closer to 0 from right, and the value of fx come closer and closer to the 4. That means limit when x approach to the 0 from right for the function is equal 4. And when we approach from the left to the 0, the value of fx approach to the 4 too. That means the left limit is 4. Therefore, the limit is equal to the 4. Note, the above example explain how we can estimate a limit graphically. If you have a gap point like this, it gives us a value of limits and function is not defined. As you can see in this graph, this point is C limit when x approach to C fx, but fc is not defined. If we have a full point, it gives us a value of function and limits. Here, this point, when x is c, is cfc, and limit is fc equal to the fc. That means this point gives us limit and the value of function. Example, find limit of the function fx equal 1 when x not equal 1 and 0 when x equal 1 as x tends to 2. First of all, plot the graph of the function using points. It became like this. And now we have 2 points. Read these 2 points. This one is 2, 0, 2, 0, and this one is 2, 1. The full point 2, 0 give us the value of the function. That means f of 2 is equal to 0. And the gap point give us the value of limit. That means limit when x approach to 2 for fx is 1. Take the value of y. Example, find the limit of the function fx equal x minus 1 when x is less than 0, 0 when x is 0, minus x minus 1 when x bigger than 0, as x tends to the 0. First of all, plot the graph of the function. Take the first part, x minus 1 when x is less than 0, fx equal x minus 1. And now, because it is the function of line, then we need only 2 points to draw the graph of it. Then take 2 points. One of them must be 0, and the second one must be less than 0. Therefore, we take minus 1 and 0. When we replace minus 1 here, it becomes minus 1 minus 1. It's equal to minus 2. Therefore, when x is minus 1, y is minus 2. And when x is 0, y is minus 1. And plot these 2 points. Here is 0 minus 1, and here is minus 1 minus 2. And we take the third part, when x is bigger than 0, then fx is minus x minus 1. Again, take 2 points. One of them must be 0 and other bigger than 0, which is 1. When we replace 1 here, is minus 1 minus 1 is minus 2. And when we replace 0, it becomes minus 1. Therefore, when x is 1, y is minus 2. When x is 0, y is minus 1. And draw these 2 points. When we have 0, 1 here, and we draw 1, minus 2 here. This is the graph of the second part. The third part, x equal to 0 is 0. It is a point 0, 0. And now you have 2 points. The full point is 0, 0, and the gap point is 0, minus 1. The gap point 0, minus 1 give us the value of limit. Therefore, limit when x approach to 0 for fx equal minus 1. And the full point give us the value of function. Therefore, f of 0 is equal to 0. Limits that fail to exist. This is happening when we have a rational function. After we replace the value of the x in this function, if in this kind of function, we will get a number over 0, which is not defined. And we have 3 behavior in this case. The first one, varied behavior with right and left. That means fx approach a number when x is approached to c from the right. That is different from that when x approached to c from the left. That means the limit from the right not equal the limit from the left, or limit when x approach to c from right not equal limit when x approach to c from left, or right limit not equal left limit. That means the limit of x approach to c for fx not exist. If a function at one point consists of 2 parts, then the right part from the point determine the right limits. Here, when x is equal to c, the function became 2 parts. One of them is from right. It gives us the right limit. Here, the right limit is equal k. And the point, this point is c, and limit of x when c approach to c. When x approach to c, and this point give us c and limit when x approach to c from right for fx. That means the right limit is equal k. And now, and the left part of the point will determine the left limit. Here, give us the left limit. Limit when x approach to c from left, fx is equal to L. This point is c, and limit when x approach to c from left, fx. As you can see, L is not equal to the k. Therefore, right limit not equal to the left limit, and limit is not exist. Only read the 2 point and the value of y gives you the limit. Find the limit of the function fx equal minus x squared plus 4x minus 3 when x is less than 2 and x plus 1 when x is bigger than 2 or equal to. Plot the graph this function like this and read these 2 points. This one is 2, 1 and this one is 2, 3. This one gives us a right limit, therefore the right limit is 3, and this one gives us the left limit, therefore the left limit is 1. Because 3 not equal to 1, therefore right limit not equal the left limit and limit is not exist. Varied behavior. Example 3 from your book show that the limit x approach to 0 absolute value of x over x does not exist. Plot the graph of this function is like this. As you can see, when x is 0 we have 2 points here, 2 gap points. This one is 0, minus 1 and this one is 0, 1. The 0, 1 gives us the right limit. X approach to 0 from right is 1 and this one gives us the left limit. Therefore limit when x approach to 0 from left is minus 1. Because 1 is not equal to minus 1, therefore right limit not equal the left limit and therefore the limit not exist. Varied behavior. Check it out. Given the function fx is equal x minus 1 when x less than 0, x plus 1 when x is bigger than 0, show that the limit when x approach to 0, fx does not exist. Plot the graph of this function. Take the first type, fx equal x minus 1 when x is less than 1, fx equal x minus 1 when x is less than 0, and now we take 2 points. One of them is 0 and other is less than 0. Let it be minus 1. Replace minus 1 here. Minus 1 is minus 2. And replace 0, 0 minus 1 is minus 1. Therefore, when x is minus 1, y is minus 2. And when x is 0, y is minus 1. And take other part, fx equal x plus 1 when x bigger than 0. And take 2 points. When x is 0, y is 1. When x is 1, y is 2. And now plot the graphs like this. As you can see, these 2 points, 0 minus 1 and 0 1, are give us a limit. 0 1 because the function is at right of the 0, therefore give us a right limit. Therefore limit when x approach to 0 from right is 1, and limit for x approach to 0 to the left is minus 1. Because 1 is not equal minus 1, therefore right limit not equal left limit, and then limit is not exist. Limit that fails to exist. Unlimited behavior. The values of fx increase or decrease without bounded as x approach to c. As you can see in this example, show whether the limit x approach to 0 fx exists or not for given graphs. As you can see, when we approach to the 0 from right side of 0, the function become bigger and bigger, or increasing without bounded. Therefore, the limit of right side is positive infinity. And when we approach from the left side, the graph is increasing too without bounded. That means the limit of the left side is positive infinity. Here we can say that the limit when x approach to 0 is positive infinity, but still limit not exist. Example, show whether the limit x approach to 1 fx exists or not for the given graphs. Here, when x approach to 1, you can see that the graphs goes down. That mean is decreasing without bounded. Therefore, limit from right is negative infinity. And from left, when we approach, the function goes down too. That means goes to the negative infinity. Therefore, limit x approach to 1 from the left is equal negative infinity or minus infinity. Here we can say that limit when x approach to 1 for fx is equal minus infinity, but still limit not exist. Show whether the limit of fx when x approach to 2 exists or not for given graphs. Here, when we approach from the right side, you can see that the graph of the function increasing without bounded. That means the right limit is positive infinity. But when we approach to the 2 from the left, you can see that the function goes down and decreasing without bounded. That means the left limit is minus infinity. Therefore, limit is not exist. Show whether the limit fx approach to minus 1 fx exists or not for given graphs. Here, when we approach from the right side of minus 1, you can see that the graph goes down. That means decreasing without bounded. Therefore, the right limit is minus infinity. And when we approach from the left, the function goes up. That means increasing without bounded. Therefore, the left limit is positive infinity. Limit is not exist. Limits that fails to exist. The third behavior is oscillating behavior. The value of x are oscillating between two fixed values as x approach to c. Example, discuss the exactness of the limit when x approach to 0 for cosine 1 over x. If we draw the graph of this function is like this. As you can see, when we approach to the 0 from the right or the left, or we are coming closer and closer to the 0 from right and the left, you can see that the value of y is oscillating between minus 1 and 1. Therefore, the limit is not exist. Discuss the exactness of limit x approach to 0 for sine 1 over x. As you can see here in this video, that these 2 points oscillating between -1 and 1 when we become closer and closer to the 0. Here you can see from left and the right, therefore limit is not exist. Show whether the limit x approach to 1 if x exists or not for given graph. Here you can see when we approach to 1, the value of y oscillating between -2 and 2, -2 and 2. Therefore, the limit is not exist. Here we came end of the lesson. Please subscribe the page and share it with your friends so that everyone will benefit and get each new videos. Write your comment and press like. Thank you for watching and goodbye.